Welcome back to Science Land with Miss Porter
and Miss Stilfen.
Today we are going to be looking at crystals. And let's review how we're going to get to crystals.
Yes.
What have you got there, Miss Stilfen?
I have our salt and water solution that we created in the last lab. And remember, we added the salt to the water, stirred it up. Can't see anything in there.
But it is in there.
But it is in there. We weighed it, and we found that it does have mass.
So we know for sure there's salt in there, even though it's broken into such small pieces that
Yes.
we cannot physically see it.
Exactly. So what we are going to do now is we have the salt water solution there, and I'm going to pour it into what we call an evaporation dish.
And we're trying to separate the salt from the water. Remember, every kind of mixture can be separated, but depending on what your mixture is, you may have to use different tools.
Exactly.
We used a metal screen for gravel, and that worked because the screen holes were small enough to let the water go through, and the gravel was too big to go through.
Exactly.
What about the paper filter?
We used the paper filter, and that managed to stop the powder from going through, but allowed the water to travel through. But it didn't work with the salt and water solution. It managed to travel right straight through filter paper.
So, because we couldn't use metal screens or paper filters for a saltwater solution to separate the salt from the water, we have to use a different tool, and we're actually going to use a process called evaporation. And evaporation means that the water, which is in liquid form in our evaporation dish, is going to go through a phase change. It's going to go from being a liquid to turning into a gas and becoming part of the air that surrounds us, because water is a combination of many different gases, and water vapor is one of those gases. So we would put this out somewhere maybe near a sunny window,
Yes.
and a few days later we would notice that the water was gone and the salt was left behind. And through the magic of Science Land,
Exactly.
we have here an evaporation dish that has salt crystals in it. Now, while Miss Stilfen's getting the camera there, I just want to point out that the scientific name for salt is sodium chloride. So what we have here are sodium chloride crystals. And a crystal is a solid form of a material that can be identified by its properties, such as shape, color, and pattern. And so every time we see a salt crystal, we would be able to identify it because of its shape and the pattern that's in it. Everything that creates a crystal, every material, that material, the pattern is different in a crystal. So if we had a crystal from Epsom salts, it would look different than from sodium chloride. If we had citric acid crystals, they would look different than Epsom salts or sodium chloride. Now we have some questions that we discussed in class when we did this lab, and that you would need to think about now, because if you're watching this, it's because you weren't in lab, or maybe you want a reminder of what we talked about in lab. So we have 4 questions, and when you look on the web page, chances are you will need to do a written response to these.
And some drawing.
And some drawing, because we drew in our science notebooks or on some kind of a worksheet.
Yes. Right.
So the first question that we would ask you to think about is, what happened when the salt water solution evaporated? And that would be a chance for you to practice your definition of evaporation, to tell us what happened to the water, what happened to the salt.
And the next one is, what is the material in the dish? You just got a chance to view it up close. So now what is it?
And this material is salt, but we're going to be looking at the differences in a moment between what we put in the water and what happened after evaporation. So what happened to the water that was in the mixture? It would be kind of neat for you to maybe draw what you think evaporation looks like. Remember, in your science notebook, you don't have to be right, you just take an idea for a walk.
Exactly. And then our last question is, does the salt look the same as it did originally? And you need to kind of explain that, and we'll show you, again, for those of you that weren't here, what we started out with and what our end product looks like.
And we selected some large, beautiful crystals and put them on black paper so that you could really notice the properties of a crystal and the properties of kosher salt. And I want to point out that these are the same material. The only difference between these two is that one of them got dissolved in water, so it broke down into smaller pieces than what it started out as. And then when the water evaporated, those pieces of salt got together again and created crystals. And we have some very nice big crystals for you to see and really look closely at, because a crystal has a particular shape and a pattern. And if you were going to look at one of these big, lovely sodium chloride crystals, you would want to notice some properties of it. And through the magic of science land, and we may have to pull back a little on this, we've come up with a drawing that we saw happening again and again in people's science notebooks of a square with an X throughout it.
Yes.
So this is the shape, and this X is the pattern. And anytime you see something with that shape and pattern, even if you didn't make the solution and evaporate the water yourself, you can automatically know it's a sodium chloride crystal.
Exactly.
Some crystals of sodium chloride got really fancy. They had 3 dimensions to them. They looked as if they were stacked on top of each other, and that's what we're trying to show here. But even if they were crystals of salt piled up on each other, they were all still square and they all had X's in them.
Exactly.
So square is an important word to have in your notebook to describe this. Shiny. We noticed that when we tilted this a little bit, you could see light shining off of them. They're sparkly.
Yeah.
We also used the word translucent. Lucent or lux means light in Latin. Trans means across. So translucent lets light shine through it. And another important property of salt crystals is they're 3-dimensional. So noticing that this is how we started out, and this is what we got after dissolving and evaporation happened. But I'm going to do something here that might make us a little sad. If I crush these, suddenly they look a lot like the salt we started out, which makes you wonder, what does the salt look like when they go into salt mines and they dig it out, because that's how we get salt to our table. People dig it, or they evaporate seawater, and then they pound it into small pieces that will fit through our salt shakers. So I'd love to go into like a cave with salt crystals in it and see how big they get.
So
wouldn't that be
neat.
cool?
Yes, it would.
So remember, a crystal is a solid piece of material, and it happens when the liquid part of a solution, the solvent, has evaporated, leaving the solute, the solid part, behind.